Students, let us begin with the next lesson from chemistry, that is structure of atom. By now you have understood what is an atom, right? And also you learned about molecules and ions, right? And we also learned about John Dalton's atomic theory, right? According to John Dalton, we know that all the matter, or you take any matter, it is made up of the tiny particle called an atom. Yes, that is true. Because when we talk about element, or you are talking about compound, or you are talking about mixture, basically they all are made up of elements. That is, if you leave elements, if at all you are talking about compound and mixture again is made up of elements. So what is element made up of? Element is made up of tiny particle called an atom. So if you are talking about compound will be made up of two or more elements, right? So when we are talking about compound will be made up of what? So let us take one example for compound, water. So water is made up of two elements, right? Or you are taking up carbon dioxide, it is again made up of two elements. Or you are talking about sulfuric acid. So this is sulfuric acid. So hydrogen, sulfur and oxygen made up of three elements. So basically compound is also made up of what? It is also made up of elements. And you are talking about mixture. Mixture is also made up of different kinds of elements which are combined in different ratio. So what we have to understand, you take any matter, they are made up of elements. So what is an element made up of? An element is made up of, an element will be made up of what? Atoms. So we can say matter is made up of this tiny particles called atom. That is what we learned in the previous chapter. That's what John Dalton also told. John Dalton told that atoms are indivisible, right? What did John Dalton say? John Dalton said that atoms are indivisible. Indivisible. That means it cannot be cut. It means what? Uncuttable. Okay? Uncuttable. Atomio. Atomio means what? Which cannot be broken. Uncuttable. Okay? That's what he told. And now, when John Dalton postulated all this thing, so the scientists started working based on those theory and all. Then they started getting doubt. If all the element is made up of atom, then why one element is differing from other element? Of course, naturally, isn't it? Because elements are made up of, all the matter is made up of atom. If all the matter is made up of atoms, then all the elements of the matter should be similar, should be same. Why it is not so? So that question came. What was the question? The question was, why elements differ from one another? Why elements differ from one another? Because we know very well, when I take one example, say for example, I take iron. Iron is an element. Let me take gold. Gold is also an element. Okay. Let me take silver. Ag is silver. And Hg is mercury. They are all elements. But aren't they different? They are different, of course, because you know very well. Iron, you know, right? The iron particles, you know. When iron, the properties of iron, you know. Gold, you know. And mercury is liquid, right? And all these are solid in state. So the question arises, right? Why elements differ from each other? Then they also started thinking, pondering over. Why? Do you really think the atoms cannot be further divided? Can atoms never be further divided? Okay, so those questions started coming up. Okay, that is when they started doing more of research work, more of experiments took place. Now we know very well atoms are made up of the three fundamental particles, the three subatomic particles. Now at present we have around 31 subatomic particles have been discovered. But when we talk about the fundamental particle of an atom, it is always those three particles, that is protons, electrons and neutrons. These three together forms the fundamental particles of an atom, okay, or atomic particle of an atom. That much we have to keep it in mind. Okay, but coming to know that this fundamental particle, that is atoms can be further divided or can get tinier particle than atom. It was not an easy task, we know very well, because several researchers, several experiments, several investigation was taken place, carried out by various scientists. That is how we came to know about this three fundamental particles of an atom. Okay, now we have learned in previous class, that is in 8th standard, we learned, right, how they discovered these particles with the help of the discharge tube. You know very well, discharge tube, the experiment. Okay, so we will know that after discovering the discharge tube by William Crookes, right, and the experiment carried out by William Crookes, later on by different scientists, which helped in discovering various subatomic particles. I hope you remember this experiment, right? So this is positive sign. So this is electrode. You know very well. These are electrodes. This is an electrode, this is an electrode, okay, and this is the ion battery, okay, and this is the glass tube. This experiment you remember, isn't it? Okay, so now, so a gas was filled inside the discharge tube, and there was this vacuum pump was there, right, which will help in reducing the air pressure inside this discharge tube. This is the discharge tube. It was designed by William Crookes. William Crookes. Okay, he designed this discharge tube. Later on, there was a lot of other models were done by different scientists, but basic model was given by William Crookes, and he carried out an experiment using a gas, and when he reduced the pressure in the discharge tube by using this vacuum pump, and when a current of voltage of around 10,000 was supplied, okay, you could see that there was, so this is, you know, these are electrode, as this is positive side, this is called anode, and this is the cathode, because it is connected to the negative side. So when the current was passed, at certain, when the pressure was also decreased, they could see a glow, a faint greenish glow was seen behind the anode, okay, and they carried out different experiment to prove from which side that rays are coming, whether it is from the cathode or from the anode. You remember they kept that cross and they kept the paddle wheel, all those experiments which proved that the rays were coming from the cathode. The rays were coming from the cathode. Okay, as the rays were coming from the cathode, it was called cathode rays. It was called cathode rays. Then several experiments were carried out. Even J.J. Thomson, you remember, right? J.J. Thomson also carried out the experiment, and he was the one. That is Sir J.J. Thomson. Sir J.J. Thomson discovered one of the fundamental particle of an atom. Which is that one? Yes, it is electrons. So J.J. Thomson discovered one of the fundamental particles, that is electrons. Okay, right? Then later again the experiment were carried out by different people, different scientists. Okay. And using the cathode, this discharge tube only they used, but little bit variation was carried out. And by then, meanwhile, somewhere, some other place, one more scientist also was working using the same discharge tube. That is, using the same design discharge tube, but he brought a slight change. He brought a slight change in the cathode electrode. In the cathode electrode, cathode is the negative side. He brought a change. What did he do? He positioned a perforated cathode. Perforated cathode was placed. You know what is perforation? Perforation. Peripheral, you know very well. Perforation means what? Pores. So he made it brought slight change in the cathode. He made tiny holes in the cathode. See, when the rays at certain point, when the pressure is decreased, maybe the chances are there some rays were emitted from the anode also. So how to make cord, right? So what he did, because usually what will happen, the positive charge will move towards the negative charge and the negative charge will move towards the positive charge. Now what? Just to make out whether any rays are emitting from the anode. So when we place this perforated cathode, he could see that there was a faint greenish glow even towards the that is beyond this cathode, perforated cathode, indicating that rays have passed through these holes. These was called canal. The perforation is called canal, and because of that it was called the canal rays. Okay, it is also referred as anode rays. The canal rays are also called anode rays because the rays were coming from the anode. Okay, and as it is moving through, as it is passing through the perforation, which was referred as canals, that's why it is called canal rays or anode rays. These are positive rays. These are positively charged. See, we have learned it in 8th standard. How we come to know whether it is positively charged or negatively charged? You remember that experiment wherein they keep the negatively charged particle, a plate which is negatively charged and a plate which was positively charged was placed near the cathode rays and the electricity was passed. Okay, if the rays are positively charged, what will happen? The rays will deflect. It will deflect from this positive charged plate towards the negative charge plate, right? So that proves that it is positively charged. Okay, so everything was done for cathode rays. Remember that what we have learned in 8th standard. Okay, so this is called canal rays, and later it was discovered they are made up of positively charged particle, and it was given the name protons. It was given the name protons. The protons are the fundamental particle of an atom, and protons were discovered by Eugene Goldstein. Okay, he discovered the protons, and by then one more scientist by name James Chadwick discovered the third fundamental particle of an atom called neutrons. So one of the theory or postulate given by John Dalton was disproved, which is that postulate, that is atoms are indivisible. Okay, so that was disproved. So in the beginning atoms were told, what was it told? Atoms are indivisible, or you can say indestructible, of which cannot be further divided. That was the theory given by John Dalton. Now, after all these experiments carried by various scientists, we came to know that atoms can be divided. Atoms can be divided. Okay, further, atom is not the smallest particle. Atom is made up of 3 more smallest particles. Which are the 3 smallest particles of an atom? It is the protons, neutrons, and electrons. Okay, protons, neutrons, and electrons. And now you know protons are the positively charged. Protons are positively charged particle. Okay, and neutron doesn't have any charge. It is neutral, and electrons are negatively charged. Okay, right? Okay, who discovered proton? Proton was discovered by E. Goldstein. E. Goldstein is nothing but Eugene Goldstein. Neutrons, James Chadwick. Electrons by J.J. Thomson. When J.J. Thomson was working on the this one model of an atom, the neutrons were not yet discovered. Okay, only the protons and neutrons. So, which are the 3 fundamental particles of an atom or subatomic particle? It also means the same, subatomic particle, or you can call it as fundamental particle. So, which are the fundamental particles? There is protons, electrons, and neutrons. And these are the people who discovered, scientists who discovered. So, this column is discoverer. So, proton was discovered by Eugene Goldstein in the year 1886. That's how when he started with this experiment. And Sir J.J. Thomson in the year 1897. And neutrons were discovered by James Chadwick. That is during the year 1932. That's when they started the experiment. So let us see the charges. So the protons carry positively charged particles. Okay, they are, that is positively charged. Okay, so it is positive, and electrons are negative, and the neutrons are neutral, doesn't have any charge. Usually protons will be denoted like P, and this is E. Okay, understood? P and E. E is electron and P is proton. And coming to their mass, the mass of proton and neutron, it is almost equal. The magnitude is equal. Whereas coming to the mass of electron, it is negligible. Okay. So the masses of proton is 1.67 into 10 to the power of minus 27 gram, and whereas the electron is 9.11 into 10 to the power of 31 minus 31, and here 1.67 into 10 to the power of 27. That is the mass of both proton and neutrons are equal, same, whereas the electron is almost negligible, very negligible. Almost you can say this, the mass is very least. Okay, so that's about the fundamental part. Now we understood protons are positively charged and electrons are negatively charged. So the scientists started wondering how could they balance the charges, and we know very well an atom is actually electrically neutral. An atom doesn't carry any charge, because we have learned it in previous lesson. When I write a sodium atom, I just write any. So a chlorine atom, I just write Cl. But the minute I write the charge sodium plus, then it is not an atom, it becomes ion. That much we have learned. So, but previously, before the research work, everything, so the scientists were thinking, okay, an atom is made up of positive charged particle and negatively charged particle. So how do they balance each other? Because you know very well, when positive charges and negative charges, they will attract each other. So how an atom remains stable? That was the question. And somehow they felt like maybe the proton is present somewhere in the middle, and the electrons can be peeled off. It can be removed. So all these questions were raised, right? And that that again further helped them to continue with their research, as they started actually wondering what might be the structure of an atom, how these particles will be arranged. So that is what we are going to learn, the different models proposed by different scientists for how the particles are arranged, that is the structure of an atom. Okay, so let us see the different structures proposed by different scientists. Okay.